Welcome everyone to the Comet Industry Q&A series. We are so excited today to have a couple of awesome guests speaking with us today about machine learning for creative user experiences interfaces. There's a lot of directions we can take this conversation, but these two folks are awesome folks to have as part of that conversation because they built some really cool things on different platforms at the intersection of augmented reality and human-computer interaction and all these kinds of different experiences. So we're thrilled to have these folks here. Just a couple quick notes as we get started. The way this is going to work is Drew and I, which we'll introduce ourselves here in a moment, but we're the representatives from Comet. We will sort of just approach this like a Q&A where we ask both our guests a few questions about their work and about different topics we had kind of settled on. And then we'll also be taking questions from attendees as well. So if you have a question, if you look in the Zoom window and the bottom toolbar, there should be a Q&A. It's like two little comment boxes. You're welcome to submit questions you have for these folks whenever you have them, whether it's in response to something they say, or if you just have a general question that pops into your mind. And we'll take about 15 minutes at the end of the chat and pose those questions as much as we can to our guests. So how we'd like to get this started is I can start by introducing myself, and then I'll have my colleague Drew introduce himself, and then we'll sort of jump right into it and have the guests introduce themselves and kind of tell their story a little bit and get us kicked off. So I am Austin, the head of community at Comet. Kind of a nebulous term, as some of you may have heard me say before, but essentially I do things like this, community events that talk about pressing issues in data science and machine learning, understanding what folks are talking about and try to find ways to host events and do different initiatives that build our community as well. So just appreciate all of you being here today and yeah, excited to jump into it. Drew?
Hello, everyone. So my name is Dhruv. I'm a data scientist at Comet, working on growth and community initiatives with Austin. Super excited for this talk today. Victor and Hart have both built like some really amazing things with ML and really like pushing the boundaries of what can be done with these models on the edge. So I'm really looking forward to this talk.
Okay, so to kick things off, kind of jumping into our first question, and this is sort of just like an introduce yourself question. And I'll start with you, Victor. Tell us a bit about your background and specifically about your journey as it relates to finding ways to creatively use machine learning in your work.
Hi everyone. It's good to be here, talk to all these brilliant, interesting folks. My name is Victor Dibia. I'm currently a principal machine learning research engineer at Cloudera Fast Forward Labs. So with regards to my background is sort of multidisciplinary. And so I started out software engineering, distributed systems. I did a bachelor's, master's in that area, a bit of cryptography too. And sometime in 2011, when I was done with the master's, I recall that I got interested in doing some startup work. So I moved to West Africa. And there I founded a startup company where we're trying to solve problems for the African market. And so as at this time, internet penetration was just becoming a thing in that region of Africa. And people were just beginning to get like internet-enabled smartphones. And so two of the problems that were sort of really strong back then was that the content on the internet and in app stores was designed for users in North America and Europe. And so that's just what was available. That was the market. And so there was just not a lot of things for users from Africa to consume. And so I spent some time building things like local language games using things like Cocos 2D. So it's a 2D game engine. And so just to create stuff that caters to the African market. And the second problem back then was that as users came online, merchants would begin to set up online storefronts, but there was no good way for them to accept payments. And so some of the work I did was working with banks to create like nice mobile SDKs that developers could integrate into their apps and collect payments. And after this, I decided to do a PhD in information systems. And I did that at City University of Hong Kong. And so I spent a couple of years in Asia. And this PhD was focused on aspects of human-computer interaction. So we're trying to use quantitative and qualitative methods to sort of understand how users make decisions as they interact with interfaces. Following that, I joined IBM Research. I joined a group called the Cognitive Environments Lab. And so this was a primarily HCI, human-computer interaction group, but we're paired really closely with the applied machine learning or core machine learning group at IBM. And the goal was to take some of the AI models and start to build things like multimodal interactive spaces. Essentially, you could walk into a room, and this room is equipped with microphone arrays, cameras, sensors, and you could do things like, oh, tell me about this, tell me about that, show me this, show me that. And essentially wanted to merge like voice interaction, pointing gestures, and visualizations to create good experiences. And that's actually where I met Dhruv. And so we worked on this nice project where we're trying to essentially build a system that helped blind people navigate small spaces. And one of the interesting things from that was that to solve that problem, we need to find good ways to track hands in real time and do it fast. And so one of the outputs of that was that some of the hand tracking models we experimented on later became this thing that I created called Handtrack.js. And so some of you might have seen the Handtrack.js library. It's just a nice little library that lets you use like 3 lines of code, and then you can easily start to track hands in the browser. And more recently, I'm at Cloudera, and my work is applied machine learning research. And so we're taking things coming out of academia, we're building prototype solutions to help our customers understand how they can solve problems with machine learning. And I also spend time helping advise on the user interface and interaction for some of our products. And my general research interests are in like, how can we improve user interactions with machine learning models? And how can we optimize these things? So things like automated generation of visualizations used from data, things like Handtrack.js. And also, I also spent some time building interactive interfaces that let people sort of build intuition on how machine learning models work. So pretty long background, but that's kind of where I'm at now.
No, that was great. I could see some of the through lines from those experiences. Really, really interesting stuff. How about you, Hart? I know I'm from what I know about you, your background's a little bit different than that. But yeah, share with us your journey into this sort of intersection of machine learning and user experiences.
Sure. So if we go way back, really, I've been working with computers since I was a kid. I was fortunate to have like my uncle gave us a Commodore 64. So this is dating myself a little bit, but back in the mid 80s, and that was really my entry point into computers. And to load anything on the Commodore 64, you'd have to type in a basic command. So something like load star.star, (8, 1), which was like giving a basic instruction to load the disk memory onto the machine. And I didn't really understand what that meant at the time, but that was kind of my entry point to computers. And I was fortunate to grow up kind of during that golden age of computing, where every generation of computer was like a significant step up from the next one in terms of computing power. I would eventually, and when I was around maybe 12 years old, I kind of started experimenting in DOS with Quick Basic, and that's how I learned to program, was with the manuals, within Quick Basic. And so this was before the internet really existed to any degree, maybe 1994 or so. And I lived in a very remote area with poor dial-up. Like, it would take, like, to give you an idea, it would take like maybe 8 hours to download a couple of megabytes of data. So very slow connection, no internet references or Google to learn things. So it was all from manual at that point. Pardon the background noise, someone's vacuuming house. So that would kind of get me into computers, and I studied electrical engineering in college, which was not directly related to computer science, but I went to school right at the height of the dot-com boom, so I couldn't even get into a computer science program at UC San Diego. And So I basically spent 5 years of my life getting a degree that I never used. And as soon as I started applying for electrical engineering jobs, the first one I actually got, interviewed in person for. There's a couple of PhDs that called me into the interview room, and they had me try and write on a whiteboard some very basic problems that I had forgotten, from my freshman year. So I was just kind of sweating bullets up there, not knowing what I was doing. And they kind of laughed me out of the interview. But the upside to that was that the CEO of the company called me into his office after the interview, and he said, I saw these websites you had built in your portfolio, and I've got to say, why are you interviewing for this electrical engineering job? You shouldn't be doing computer stuff. You're obviously much more capable at that. And so that kind of got me back into the computer world. And I had interviewed for a startup company shortly after that. And that was my first job out of college, was for a small startup in downtown San Diego. And they had later got acquired by AOL. And that was kind of my entry point into the entrepreneurial world. And since then, I've started 3 companies, and the latest one is 2020 CV, which I started in 2017. And we're really focused on building machine learning and computer vision solutions for augmented reality. So we build a lot of silly ideas, like we were talking with Austin before about a lightsaber that came out of a piece of rolled up paper, or talking dogs, or virtual hand puppets. A lot of my work is with hands as well. And so more recently, I've been working more in Lens Studio, which is Snapchat's kind of tool for building AR things, just because it's a lot easier to prototype. But outside of that, I, really just interested in kind of pushing the limits of machine learning, computer vision, and how that relates to augmented reality.
Thanks so much, Hart. I might return to some of your background at a later point, because I still want to hear this story about you cold emailing Mark Cuban. I've heard rumblings of this story, and getting an investment. So we might return to that later. I want to jump into kind of, now that you guys have shared your journey and how you sort of approach this work. So we're talking a lot about the way humans and computers interact writ large, whether that's through these augmented experiences or whether it's through, computer vision specifically. I guess I'm curious, how would you describe the potential that machine and deep learning have to enhance these kinds of experiences between humans and computers? How do things like machine and deep learning shape how humans and computers actually interact? And I'll let whoever wants to take this one and jump in.
Sure, I can. Quick thought. So I think one of the fundamental things about computers is how we provide input into them. And up until maybe the last decade, that was mostly just keyboard, mouse, and touch device. Outside of that, and voice to a degree with Siri, and whatever the Android solution is, OK Google. And I think that it's humans are inherently visual people, so really the best way to interact with computers is through some kind of vision. If you think about it, I guess we communicate with each other mostly through voice, but a lot of that is visual cues as well. And if I point at something, it signals an intent of what I'm talking about. So I think the same thing applies to computers, and machine learning plays a large role in understanding both audio through natural language processing and vision, as with all these convolutional neural networks and everything that's come out of machine learning research over the past decade. So I think it's really interesting to see where things go in terms of how our computing interface changes over the next decade, whether that's through augmented reality glasses. And I've got a pair here I can share with you guys. These are the spectacles that Snapchat just released, and these I've had a chance to play with. Also provide a kind of a new way to interface with computers, and that my hands are free and I'm not forced to type anything or hold anything. And I think that opens some new doors to the ways we'll interact.
That's awesome. I like the idea of thinking about the history of how we give inputs to computers. I think that's like a really important piece of context there. How about you, Victor? Same question posed to you.
Yeah, so I completely agree with everything Hart just said. And so on a high level, though, I think there are two main ways in which machine learning, deep learning can sort of interact and shape and improve user experience. So the first one is what Hart mentioned, just providing completely new modalities for interaction. And so, like I said, beyond keyboard and mouse, I mean, historically, we know how to make like keyboard and mouse interactions work well, and use nice transitions, animations, but can we do better? And machine learning can help here. So it's pointing, gestures. In some areas of research, we would refer to this as body as input sort of interaction. So using parts of your body as the input modality. And there's a ton of research that shows that that approach drives a lot more engagement compared to the keyboard and mouse. And here engagement means the degree to which the tone and style of the interface makes the product more pleasant or satisfying to the user. And so, just body as an input. And so beyond vision, there's also this new project from Google where they are integrating miniature readers into smartphones. And so based on that, you could use gestures. And so the reader emits some waves. You can process the interaction between body parts and those waves, and then you can map that to controls. So that's another interesting direction. So that's one whole area. Another way I think machine learning can improve user interaction is just by reducing cognitive load. And so in the HCI and user experience research area, a good user interface is the one that helps reduce the cognitive load for the user. And this is particularly salient to deep learning because a lot of the advances we're seeing in deep learning are like advances in machines now being able to solve perceptive tasks. And so these are tasks where like humans need to do things like seeing, hearing, listening, and all of that. And these things take a ton of brain power. And so if you can develop new tools, it's essentially any sort of task where there are some of these perceptive components to it, and you can correctly get a machine to solve them. These are just good opportunities for you to apply machine learning. And so one example is something I worked on a while ago. I started this work, I think 3 years ago. It's the whole idea of automatically generating visualization. So data visualization is a great way to summarize the insights within data. However, many people just didn't have the skills to select the right encodings. Do I use the bar chart, the pie chart, maybe not pie chart, the bar chart, I don't know, line chart, this sort of thing. Even when I do that, what fields in the data do I use? And even when I do that, what transformations do I apply to the data? Do I do an average, this sort of thing? So you need some brain power to make all these decisions. And so what if you could get the machine learning to, let's say, model to take in your data and generates 5 to 10 visualizations that make sense with these for your data. And even if you don't end up using any of the things it recommends, it also generates code, which you could then modify. And so it just reduces the cognitive burden there. So these are the two areas of modalities where I think machine learning can help. So reduce cognitive load and improve engagement by offering new modalities for interaction.
Awesome. That's a great two-pronged approach. And I think around engagement is something that is kind of leading into Drew's first question that he wants to ask. So whenever you're ready, Drew, take it away.
Yeah, so my question is more around, I guess, like model evaluation, right? So in more classical machine learning, you have like accuracy or mean squared error, right? So if my model is supposed to predict 100 and I predict 150, I'm off by 50. So I know what that performance delta is. But when you are trying to build like an interactive system where human is continuously interacting with the model, there's several like sort of other factors that you have to consider to sort of assess this like qualitative metric, right? Like how smooth does it feel? How like I don't know, almost like lifelike does it feel, this interaction? So I would be curious to know what are your thoughts on like when you're trying to build this sort of user experience with an ML model, how do you evaluate model A versus model B for that sort of interaction?
Let Victor start.
Okay. Yeah. So I think that's a really great question. I think one of the first key thing I want to point out is that as data scientists, we are used to focusing on this model performance metrics, so accuracy, MSE, and all that. But really, what we should be focusing on is how well this model helps the user and supports their goals. And the second thing I want to point out is sometimes these two things might not be the same. So high model metrics may not always transform to good user experience. And so it's something that, many times when I have conversations with people building systems, or even in my own work, I need to step back and just like acknowledge these differences and sort of take advantage of like just traditional approaches in user experience literature to sort of tease out, is my model really in service of the end user's goal? And so, for example, just a quick example, you might have a model that has like 98% like accuracy when you are evaluating it in some offline setting. So you have some data, you've done it, it works really well. You put this thing into production. Let's say you're doing recommendations, and your recommendation metric, let's say things like purchases, actually goes down. But when you train the model on some offline data, it looks like it works really well, but in practice, it doesn't improve like the user's end goals. So things like maybe better purchases, or better conversion rates, that sort of thing. And there are many reasons for that. It might be that there's a difference between your test environment and your trained offline evaluation environment and your actual production environment, or there are some new interactions that are occurring in the production setting that you just can't model in your offline test setting. There are many reasons for that, but it's just a good idea to acknowledge that these two things can be different and be aware of that. And so the next thing is, if you have come up with some sort of user experience metric, if we go back to the two things I mentioned earlier, let's say you want to reduce cognitive load. So you probably need some way to measure cognitive load. And after you build your model, you train it to put it into production, you probably can use some methods from user experience research to measure cognitive load. So it might be things like after users interact with your tool, you give them some survey where they report, they have self-reported measures of effort to difficulty. Or you could have some logs where you keep track of things like the session length, task completion rate, essentially whatever you can get from things like Google Analytics, you can use that as a way to sort of measure how well changes to your model might be affecting all these other user experience focused metrics. And then you could also look at user engagement. There are many ways to sort of measure that. You could use things like observational studies, where you get a group of people to use that thing, and you sort of look at what they're doing and ask them to sort of verbalize their actions. So it's called, you could think of this as a think aloud protocol. And it turns out that as you get them to use things, and I'll say, why did you do this? Why did you do that? You might start to find like challenges that you didn't expect and things that you really, really need to fix. That's sort of impacting their ability to make progress. So these are some ideas and ways that I will typically sort of recommend people synchronize between model accuracy and actual user experience. But I know Hart has done a ton of work. He's got a ton of things people are actually using. So I'm super curious to hear his perspective.
Yeah, no, it's kind of great to hear your side of it as well, Victor, because, working as a one-person team this past 4 years, it's like a much less refined process. And, it's a very complicated problem and a good question, because just starting with the first tester being me, that presents a lot of bias into the equation. Let's just use my hand tracking for example. I move my hands a certain way, they're a certain size. I'm gradually training myself to realize what works well and what doesn't work as well with my model. So I start forming a habit of how I'm moving my hands. And as soon as I take the model outside of my own sphere of influence and to my kids or my wife or something, and have them use it, and then I realize like, oh, it's not trained for their kind of hand movement, or it's not trained for their hand size, or the lighting in this room is different than my office, so this isn't working. There's so many variables that can mess up how your model performs, and really for me it's mostly just an iteration process. There's no hard measurements taking place. It's just like, is this working okay with me? Okay, let's take it a step further. Does it work with my wife and kids? Okay, let's take it a step further. Does it work with my beta testers? And just kind of refining, looking, really the most valuable thing for me is just seeing videos of other people using things I've built and seeing how horribly it works. This is usually the best feedback. And so, things like trying to track the human hand is a very, very complicated problem, because your human hands can deform into over 1 billion positions, and add in all the different lighting possibilities and shadows and occlusion and everything else that goes into tracking with a 2-dimensional camera. You've got an infinite set of problems that are working against you. So for me, it's really just number one, I should preface this with saying, like, I don't build brain surgery tools or anything important. I build toys, which is, people have lower expectations for how well it's going to work. And that's really the only thing that's saved me thus far, is that nobody's relying heavily on these toys that I've built. So I think that, ultimately it's probably much better idea to use a process like Victor mentioned, where you have a kind of refined feedback pipeline from your users and you're building off of that. But if you're just a single developer, there's nothing wrong with just doing very crude tests and going by, does it work or not, simply yes or no, versus an accuracy percentage, because those things take time to build those tools and test and do that QA process. So really it's better to just start small and work your way up than than just trying to have this whole process to test your model.
Yeah, that makes a whole lot of sense to me. Go ahead, Victor.
Yeah, I completely agree. So for my indie projects, I usually don't go through all that complicated process that I mentioned. If you're a small team, I think the process of just like, essentially you're doing the same thing. You are essentially getting feedback. You're doing user testing. You're probably doing some sort of think aloud protocol. You're doing some observational studies. It's just that you're not doing, let's say, at scale or with a bunch of complex metrics, but you still have an iterative method to get feedback and improve your model. So I agree, Hart.
And it sounds like, it's with a lot of things with machine learning that I've been learning about, it sounds like the domain is also going to dictate a lot of how stringent you are with that. Like you were saying, if you're doing something for brain surgery or something like that, your standards are going to be much higher. And so the process you're going to go through is going to reflect that, versus if you're creating sort of more creative, just fun experiences, it's a whole lot different, and it can be a whole lot more qualitative. So I think that makes a lot of sense to think about it as domain dependent in some cases. So the next question I have, and I have a sense of what your answer might be, Hart, but I'll let you take it first. Do you all have products or software that you think use machine learning in particularly creative or engaging ways? And then sort of the flip side of that, what are some of the biggest failures you've seen? And it could be your work or other people's work or whatever, that you've seen when it comes to these kinds of creative or immersive ML experiences. So sort of a good and bad examples of this in action.
So your first question was on tools that I use or other people's tools?
Products or software that use ML in particularly creative or engaging ways. I'm kind of leaving it open-ended, so you can take that in whatever direction you think makes most sense.
Yeah, that's a good question. I think there's a lot of creative stuff being done right now with machine learning and just applying it to various ways you can build new products in the world with it. And so like I think we've seen a lot of stuff obviously with Snapchat come out over the last couple of years, and that's what I've been working with most recently. So it's been fun just to see these kind of mini experiments or prototypes that people build using machine learning. And they can even be, ranging from silly, inane filters to actual tools. Like one Snapchat person had built a tool for measuring that uses machine learning to measure like the size of the crack in a wall to tell you if there's a foundational issue with the wall or not. And I believe they were based out of Haiti, where they suffered from a lot of earthquakes over the past decade, unfortunately. And so they were kind of using that tool to determine if the building had a serious foundational issue or not, and whether it should be investigated. And then there's sillier things too that people have built that are kind of fun and creative. So just every time some new model comes out, whether it's more recently with Snapchat, they've done 3D hand tracking or shirt segmentation. I think that opens up the realm of possibilities for new filters. And I think for me the filters are kind of an entry point to seeing more serious solutions being built from that technology. Like I mentioned before with the tool versus toy analogy, people will have fun with these models before they'll try and build something more serious.
How about you, Victor? What are some things you've seen that are particularly engaging or really good examples of this, and then sort of more or less effective ones?
Yeah, so I used to work with Hillary Mason. She's a pretty well-known data scientist, and one of the things I kind of learned from her is that she said, as data scientists, our job should be to make machine learning boring. And so the idea is that some of the best technologies that we use today are the ones that sort of just blend into a regular workflow and provide a ton of value. And we don't really know it's there, but it's just there helping us. A good example is things like maps. I rely a lot on Google Maps. And so it's just something that's just there. I take it for granted. It's pretty reliable. It's dependable. I don't have to worry about it. It's just there providing value. And so I think good ML powered experiences should aspire to that level of just being boring, blending into our workflow and providing value. And one recent example is email autocomplete. So Google Gmail email autocomplete. I use it at first. When it first came out, I'm like, hey, but this thing worked really well. Would it blend into my workflow? But now I find that a lot of times I accept the suggestions that it makes, and it achieves that nice goal of reducing the cognitive burden of typing out things. So sometimes it suggests good stuff. I'm like, okay, tap, correct, enter, and I can author emails faster. And so there's like an example. Sometimes you also see recommender systems that essentially they recommend things that make sense, like you're trying to purchase stuff and you see recommendations that make sense. I think these are well done applications of machine learning. Again, to allude to, I think some of the points that Hart made about two types of ML applications. There's the ones that are low stakes and high stakes. And so for low stakes, it's mostly open and interesting, but when you start getting into high stakes applications, then I think a lot more thought about the ethics and the safety aspects of things need to be considered really carefully. And so one good rule of thumb that we like to think about at Fast Forward Labs is just how might this affect human welfare? Is there a chance that what I'm creating might adversely affect human welfare? And so I think we all know about tons of examples here. Say incorrect identification on facial recognition systems can, if used incorrectly, maybe used in some high stakes environment, can cause a ton of problems. Say medical applications of AI. So I think people building systems like this just spend a lot of thought on just making sure that you don't affect human welfare negatively, and this could turn out to be failure cases. Yeah, so these are kind of like my thoughts. There was also a nice example at the last Google I/O where they talked about a new feature in Google Photos. So Google Photos has this nice thing where sometimes it will organize some of your photos into memories and present them to you, maybe generate some video or GIFs. And they sort of talked about this situation where there were some things that users might want to forget, let's say a previous relationship or a relative that passed away, that sort of thing. And the way that thing was built previously was that you didn't have the opportunity to turn off certain features or control it. And so even for low stakes scenarios like that, there's also opportunity for failure. And so a good solution there would be to just think a bit more carefully about what that space could look like and at least offer some control to the user. So those would be my thoughts there.
I think that's a great point, allowing the user control. Go ahead, Hart.
Sorry, yeah, one thing that just popped into my mind about machine learning and mistakes and semi low stakes, but also, I'd say medium stakes problem was that Twitter had this cropping issue recently where they would favor certain faces or skin tones over other people when they crop, or certain genders or whatever the case was. And I thought it was a good example because it's a game that you can't play with machine learning because you're going to lose no matter what you do. Mm-hmm. It's like if you have two people of one gender and another of another gender, and you pick one of them and then you have the same scenario but flipped, it's creating an impossible problem to solve with machine learning. And so the easy solution is just let the user crop the photo and show them what it's going to do, but instead they try to over engineer it or just show the full photo like they've been doing more recently. And I think it's kind of a good example of machine learning failure in that you didn't need machine learning in the first place to do this. You could have just passed the burden onto the user to do it. And it's something you've got to think about when you're building these things as well.
Yeah, it's sort of the hammer and nail thing where every problem, becomes something where, machine learning can solve, and that might not always be the case. So, Drew, you had a thought?
Yeah, I think it was Hart's example is kind of touching on what Victor mentioned. Are you trying to solve for the user experience, or are you just trying to build a model? So it's, those are two different things. And I think it can get people, at least practitioners can get kind of lost into trying to build the absolute best model versus try to solve the actual problem that's in front of them.
Yeah, I agree with that. Drew, I know you've got a couple more questions on here. If you want to pick one, and also, just as a quick reminder for folks that came in late in the chat, at the bottom of your screen on the little toolbar, there should be a Q&A button with two little comment bubbles. If anyone has any questions about any of the things we've talked about so far, has any additional questions, feel free to drop those in there. We're running right on 15 minutes left, so anything you have, feel free to drop it in there and we'll address it if we have a chance to do that. But Drew, I know you've got a couple more, so it's all yours.
Yeah, actually, Victor's Google Photos example is a good segue into this question. So I think like when designing these sort of systems, do you sort of have maybe like a rule of thumb of like how much of the model's like predictive capabilities you expose to the user? Is it sort of completely hidden where they only interact with the output, or is there sort of do you design ways to either explain the prediction or the interaction or adjust it somehow to your needs? Like, curious to know what your take is on that.
Yeah, so if we go back to the example of or the general principle of trying to make machine learning boring, going by that principle, we want to hide as much of the underlying model as possible. And so I think a good ML powered user experience should just focus on the benefits to the user and not exactly what the model does or how the model does it. And I think most of the time, if you take that approach, you probably won't go wrong. And so it's true, ML models might have all these a ton of parameters. And so I think a good thing is, and this is just a UX research strategy, where you want to focus on just, let's say, the top 20% of important things the user needs to know. And most users will fall within that bracket. And every other thing you can hide under some sort of abstraction and give users the opportunity to dig in if they really, really need to. If we think of like Gmail autocomplete, you typically don't need to do anything. You just press tab. It shows the suggestions. You press tab. You accept it, or you don't you accept or you reject it. And so the opposite of that would be letting the user set the temperature of the model, the maximum sequence length. I don't know. Do I use BERT or distill BERT? All that stuff. Like the user doesn't need to know, right? So most of the users, there's a basic model that will work well for all of them. There's some basic temperature setting that's good for them. So you select, find out what that thing is. You probably need some user research to find out what those nice, good base parameters are. And then you just focus on the providing value. So this is my thought. However, there are times when you want to do a bit better than that. And so that's when we start going to medium or high stakes environments. So where the output of the model is sort of important. And so one important thing there is to give some measure of the model's confidence, or, just offer the user some additional information such that they can make better decisions. And so, for example, if I was using an app that was going to tell me if I had a skin condition or not, I want to know, is this model confident to this thing, or is it not confident? And so also when you build the system like that, the choice of model to use kind of matters. You want models that are Bayesian, like they can output principal measures of uncertainties. So neural networks typically, they will offer confidence values, but this confidence values typically are just some softmax. So these are not true probabilities. And so you want to do your best to, if possible, offer true probabilities that really quantifies the uncertainty of the model. And also, do you show numbers? Do you show, okay, 15% accuracy, 87% accuracy? Maybe not, because users might struggle to really figure out what the numbers mean. So maybe you want to do things like very confident, medium confidence, low confidence, that sort of thing. So these are some strategies that I will take this sort of environment. And by the way, there's this white paper by Google, something called the Google People and AI Research Group, where they have a ton of good advice on how to navigate user experience in AI. So it's something I really recommend. Some of the things I talked about, they go into more details there.
Nice. We can share that paper, I think, after this talk.
Yeah, so just to add on to what Victor said, I think there's beyond, what choices you're giving the user, it's also how constrained is the environment that you're asking them to perform this action in. So, I think at the high level of the spectrum, you have Apple. It just works. There's do whatever you want. It's going to work no matter what. And at the other end of the spectrum, you're essentially coaching your user to do things in a certain way. So, for example, a lot of the models I built with hand tracking weren't generalized tracking. In other words, they didn't work in every position of the hand. It was like the hand puppet one. It was trained to work on a movement, with this limited range of motion where you're kind of doing a little talking motion with your hand. And there were, I think, as long as the users understand, what you expect to work and what you don't expect to work, then you'll be okay. But the ideal scenario is that it just works and you're not letting them pick any parameters of any kind. They're just going to do whatever they want. But as I mentioned, there's so many variables. It's hard to accomplish that, especially when you're kind of pushing the edges of machine learning. So, there's probably a happy medium somewhere between those two levels where you're not spending an hour coaching them what to do, but you're also able to provide an experience that works within, a certain range of environment limits.
Yeah, for sure. That idea of using traditional sort of UI, UX onboarding or product training or whatever to sort of expose the model without actually saying, like, what's happening here is this model is making X, Y, Z predictions on the input data you're providing. I think that's a really interesting way to think about it as well. So we've got just a few minutes left. So I kind of want to end a little bit more on maybe a personal note, in the sense of, I would just love to hear you all talk about your like favorite, whether it's, the one that got the most traction or didn't or whatever, like the favorite project you've ever worked on and how it turned out and what was the sort of end result. And I'll start with you, Hart, on this one.
Okay. Yeah. So I guess I would probably say the hand puppet project I had just mentioned. For one thing, it was the genesis of this company. I, as Austin mentioned before, I was able to raise money from Mark Cuban starting this company. It was kind of a funny story. I had built this prototype in OpenCV of the hand tracking puppet, and it only worked like this position. It wasn't even this, because OpenCV just, segmenting out the hand essentially, and it doesn't understand this, but it kind of understood where the thumb was with this. So it was really only this position, the hand puppet. And I had built this prototype over a couple of months, and as some further background, I was between jobs at the point. So I had just left my last company, and I had a kid. And so I'd kind of taken a year off from doing any kind of real job. And I was, a little bit at the point where, okay, I need to pay for my kid and mortgage and all these other adult responsibilities. So it was either I was on the verge, I was applying to several jobs at the same time I was building this thing. And, I had released a video of it on like Reddit, YouTube, and nobody picked it up, and nobody, emailed it to a few people, and people were like, eh. And so really is like a last Hail Mary effort. I guess I have to rewind even a little bit further. So the first job I mentioned out of college, it was also a Mark Cuban company, and they had secured funding from him by just sending him a cold email. So I think I had this thought in the back of my head, like, okay, I could, email Mark, to start a company at some point. But I didn't know his email. I'd never met him in person, and to this day, I've never met him. But I had this idea in the back of my head, I guess, and so I Googled around for his email address, and you can find his email address through Google. It's not too hard. Semi-public. I won't share it here, but if you're curious, you can go find it. And I crafted this short email straight to the point. I said, hey, Mark, I built this prototype. I think something that Disney or Snapchat would love. And, I didn't even ask him for an investment or anything like that. I just, just said like, let me know what you think. And I got this reply. It was the one line that said, it said, what do I get and what do you want? And then it just said -M. And so I didn't even know if I had reached the right person. Like, it's like, is this this guy trolling me or what's going on? And it was like, he replied within like maybe 30 seconds of me sending the original email. So to give you some idea, he receives about 800 emails a day that he responds to. And I don't know how he gets through them, so quickly. It's mostly just one-liner responses and probably Google autocomplete, as Victor was mentioning a lot of the time. But he replied, and a couple other emails back and forth, and eventually landed an investment from him. And so that's kind of how I got started. Back to the original question, that the Puppet thing, I was later able to get working better with machine learning, and eventually I'll probably do another one on Snapchat.
That's a great story and inspiring for many reasons. The reason I like the best is that you took the year off and then managed to secure your next opportunity by creating a virtual hand puppet with computer vision. Like, that's pretty awesome. How about you, Victor? What's your favorite thing you've ever worked on?
Yeah, that's a really brilliant story, Hart. Thanks for sharing. So I guess, yeah, mine is also related to hand tracking. So there's this library called Handtrack.js. Essentially, it's just a JavaScript library that lets you track hands in the browser in 3 to 4 lines of code. And the background of that was many years ago. Like I mentioned earlier, I was working with Drew, and we're trying to build the system that helps blind people navigate small spaces. So they would have like a head-mounted goggles with like a camera feed, and we had like a view of a table where they were interacting. And essentially, the system was fairly complicated. It also had this haptic wristband. And so the goal was to use computer vision to understand the scene, and the blind person could issue a couple of voice or speech-based commands, and essentially will interpret the scene and will guide them using the haptic band to perform some action. Some of it worked well, some of it didn't work very well. But to solve this problem, you needed to track a bunch of objects and also track hands really well in multiple orientation. So egocentric orientation, like from top down and from other viewpoints. And essentially, I started to do some research there. Some of the constraints there is that you want this thing to run, you want it to be a relatively small model, you want it to run fast. And this was like 4 years ago. Of course, there's been a lot of advances in this field. And so when I was done with that project, I thought, being able to track hands is a great thing. And it'll be good if other developers can do that too. And I just spent some time essentially taking, this model was designed as an object detection model, trained on some pretty decent data, and then taking all of that from Python, exporting that to JavaScript, optimizing it, and wrapping that into a library with a bunch of really nice utility classes to make it easy to use. And I like that project because it's, most of the work I've done, it's hard to get other people to use it and actually build things on top of it. And so getting community participation can be hard. And so that library has been the most successful. I think it has like 3,000 plus stars on GitHub. Easily the most interesting thing I've done, at least in terms of interaction. And so, yeah, and people have built all kinds of nice use cases, from tools that help kids learn, let's say letters, that sort of thing, interactive games, sign language interaction, game controls, all run in the browser. So that's one of the interesting projects I've worked on.
Thanks for sharing, Victor, and Hart as well. As the head of community at Comet, I can co-sign on it. It's difficult to get the community involved. I can definitely co-sign on that issue. So any tips you got, Victor, you let us know. joking in jest there, but thanks so much to both Hart and Victor for joining us. Just a real quick note as we wrap up, we will, over the next week or so, we'll be sharing the full recording plus some of our favorite clips and highlights. So we will follow up with all of you who signed up and attended today, as well as on our social channels. So follow us on Twitter and LinkedIn and all that kind of good stuff. And then check out 2020cv.com. That's Hart's company and his website. It's got some really cool projects there. Also follow Hart on Twitter. That's where he posts his demos, and he's got some pretty cool ones up. Victor, where should folks find you? You got a website, I know, but what else?
On Twitter. I'm also on Twitter, so
yep.
Follow me on
Gotcha.
Twitter,
and we'll drop those details in the follow-ups as well in the YouTube videos that we share. So thanks so much, everyone, for sticking with us and hanging out. And thanks especially to our two guests who gave an hour of their time to us today. So thanks again, and take care, everyone. Until next time.
Yeah. And if anybody, I know we're out of time, but if anybody has any questions, feel free to, pass them through Austin, or, contact me directly on Twitter, and I'm happy to answer them.
Absolutely.
Same here.
Happy to do that. All right. Thanks, y'all.
Thank you for your time.
Take care.
Bye.